In this video, I'll be going through the Unit 8 practice exam. Part A is a bunch of multiple choice questions which are primarily about the Unit 8 note sheet that we got at the beginning of this unit. So make sure that you take some time to look through that note sheet, pick out all the information about the different vocabulary and things like that, because you're really going to have a mastery of a lot of different vocab words and concepts to be able to do well on this multiple choice section. So starting off here, it says, these are the starting materials in a chemical reaction. Hopefully you know that those are the reactants, which is C. All right, so the things that you start with in a chemical reaction, the things on the left side of the reaction are called reactants. The things that you end up with are called products. That's on the right side of the reaction. Number 2, which of the following states of matter indicates that a reactant is dissolved in water? AQ is what that is. All right, and so dissolved in water is AQ, solid is S, or sometimes CR for crystalline solid, liquid is L, and gas is G. Other than that, the rest of these aren't really anything. It says, which of the following is not evidence of a chemical reaction? So there are 5 different pieces of evidence of a chemical reaction in your notes. Make sure you're familiar with those. Melting is not one of them. Melting is a phase change, which is a physical change. If you melt something, let's say you have ice and you melt it, it starts out it's liquid water, starts out it's frozen solid water, it melts, it's liquid water. There's not a chemical reaction going on there, it's just a physical change, it's changing form. An endothermic reaction. In an endothermic reaction, energy is taken in, all right? Energy is brought in, and if you were holding it, it's going to feel cold. The reason it feels cold is because the energy that the reaction is bringing in is being brought in from your hands. So it's literally taking heat in from your hands. And so endothermic heat goes into the reaction, which means it's coming from the environment. And if you're holding it, that means it's stealing the heat from you, which means you're going to feel cold. So that's D. What does it mean when you see the following symbol? We've got this double arrow there. All right, that double arrow indicates that the reaction is reversible, which is A. In this next section, we're going to be balancing some chemical equations. For number 6, I recommend that you leave Fe until the end, because if you ever have a substance where it's just an element by itself, we kind of get a wild card here. We can write whatever number we want in front of Fe to make it balanced, and so I'd say leave that until the end, balance the oxygens first. So with the oxygens, we've got a 3 here and we've got a 2 here. This is a sort of weird situation because it's not as easy to balance this as some other things. What we have to do is we have to come up with a lowest common multiple between 2 and 3. That lowest common multiple is 6. All right? To make 6 oxygens on each side, I would put a 2 here and a 3 here. All right, so we have that lowest common multiple of 6. There's a special name for this. It's called a 3-2 switcheroo. The idea is that if you have a 3 for the subscript on the oxygen in that first substance, you put a 2 as its coefficient. And if you have a 2 for the subscript on oxygen in the product side, then you put a 3 as its coefficient, and you end up with that lowest common multiple of 6. Now for the Fe then, we've got 2 Fe2O3s on the right side of the equation, on the left side. So to get the Fe's balance, we need 4 Fe's here on the right side. Then it says to identify the coefficient for Fe. From the choices above, we've got 4 as our coefficient on Fe, so that is selection D from your multiple choice sheet. This next one, balancing it out, lithiums first seem like they're balanced, so we go to bromines. There's 1 bromine on the left, 2 on the right, so we put a 2 here to balance the bromines. That messed up the lithiums. All right, so I can put a 2 there to balance out the lithiums. All right, and then you can see the chlorines now are just balanced. It says identify the coefficient for Br2. If there's no coefficient there, it's a coefficient of 1. All right, it's an implied sort of invisible coefficient of 1. And so that means we have A for our coefficient on Br2. This next one here, a combustion reaction we're looking at, we've got a hydrocarbon with oxygen, carbon dioxide, and water. That doesn't affect how we balance it. I was just commenting there. Usually with one of these, I would start by balancing the carbons. So there are 3 carbons on the left. so I put 3 here, so that there are 3 carbons on the right. With the hydrogens, there are 8 on the left. To get 8 hydrogens on the right, I put a 4 here. All right, now I have to count the oxygens. From carbon dioxide, I have 6, and from the water, I have 4. That's a total of 10 oxygens on the right-hand side. So to get 10 oxygens on the left-hand side, I put a 5 there. And then everything is good. For number 9, Na2CO3, we've got 2 sodiums on the left-hand side, so I put 2 here to get 2 sodiums on the right-hand side. Carbonates, the CO3, there's just 1 on each side. Hydrogen, I've got 2 on the right-hand side, so I put 2 here, and I've got then 2 on the left-hand side as well. And then chlorines, you can tell, you can double-check there, that there are 2 chlorines on each side. Now, as a general strategy here, when you go through and do these, I recommend that you double-check at the end. Just go through all the elements again. Make sure they're balanced. Make sure that you haven't made some sort of mistake. So just as a general last step, just go through and count each thing again and make sure that you're balanced all the way through. I realize now that I've forgotten to put the letters over that correspond with the answer. So it said identify the coefficient for O2 for problem number 8. On O2, the coefficient is 5. That is none of the ones that are listed there. So we're going to select E as our answer. And for number 9, it says to identify the coefficient on NaCl. That is 2. So we're going to select B as our answer for the multiple choice. In this next section, we are identifying reaction types. The first one here, we've got S8 and O2 coming together to form SO2. Things are combining together into one product there. That is indicative of a synthesis reaction, which is A. Next one, Ag plus NaOH yields AgOH plus Na. In this case, we've got silver coming in. That's an element. It's reacting with a compound. That silver is displacing the sodium in the compound. And so that we've got, when you've got an element coming in and displacing an element within a compound, that is a single displacement reaction, which is E. Next, we've got hydrocarbon plus oxygen. It yields carbon dioxide and water. That is a combustion reaction. Combustion is C. The back part of this practice exam, or the back part of this exam, is all short answers, so you have to actually go through and fill in the work. It's not multiple choice, so we'll be going through those problems here. Part D is all about predicting products. The first step on predicting products is identifying the reaction type. So in this first one, we've got CaCl2 plus O2. What happens here, the O2 being a nonmetal is coming in, it's trying to displace the chlorine. Normally, okay, you'd identify here that this is a single displacement reaction. All right, and then you check the activity series. Oxygen is actually not listed on your activity series for nonmetals, so I'm going to say just assume that this reaction is going to happen, all right, and calcium, as the chlorine is going to be displaced by the oxygen, calcium ends up with oxygen in the end, all right, so the chlorine is going to end up on its own. So we have to think, if you have calcium and oxygen together, what is it going to make? Ca is 2 plus, O is 2 minus for the charges, and so if you have Ca and O coming together, they kind of fit together nicely 1 and 1, or if you want to think about the crisscross, we end up with Ca2O2, but then I always tell you with ionic substances you need to reduce, and so either way you think about it, hopefully you get to CaO as your final product there. Now, the next thing we get here is chlorine, elemental chlorine. Chlorine is diatomic in its elemental form, so it's going to be Cl2. Normally we'd balance it after this, but I told you in the directions don't balance it. You've got another part of the exam that are, all of the problems there are balancing problems, so we're going to just focus on predicting the products in this section. This next one, we've got Mg plus Cl2. That's an element plus an element. Hopefully you recognize that that is a synthesis reaction. All right, Mg plus Cl2. We can't just mash them together. We have to think Mg is 2 plus, Cl is minus. All right, we crisscross here. All right, and it does end up being MgCl2, but not just because we shoved them together, because the charges worked out that way, MgCl2. Because magnesium had a 2+ charge, chlorine had a 1- charge, then we crisscrossed, and we get MgCl2. Next one, here we've got just one reactant. If you've got just one reactant, we're going to identify it as a decomposition reaction. All right, if it's decomposition, we're going to just break it down into the elements. Elemental nitrogen is N2. Elemental hydrogen is H2. The next one, calcium plus lithium chloride. Element plus compound. This is a single displacement reaction. So I usually just abbreviate this, single displacement. All right, and then what we got here, the calcium is coming in, is trying to displace the lithium. Metal displaces metal. Now what you've got to do is you've got to check the activity series. If you look it up, you'll see that calcium is lower than lithium on the activity series, which means that in this case, they actually would not react, which means no reaction occurs. All right, in part E, we are doing a word equation. What happens here is I just describe a chemical reaction to you in words, and you have to write out the equation as it happens. And so the first thing here says liquid water is reacting with lithium metal in order to form dissolved lithium hydroxide and hydrogen gas. So we got to break it into parts. The two reactants here are the liquid water and the lithium metal. So liquid water is H2O, and it's liquid, so we do the little curly L. All right, plus. Then we've got lithium metal. All right, if it's metal, that means it's a solid. All right, it has reacted to form, so that indicates that we're going to start talking about the products. All right, it says dissolved lithium hydroxide. So for this, we have to figure out what lithium hydroxide is. Na plus, lithium. Li plus is lithium. Hydroxide is OH minus. All right, that's 1 and 1 when you crisscross, and so lithium hydroxide is just LiOH. Now I say it's dissolved here. We're going to assume then it's dissolved in the water, all right, which makes it aqueous. All right, and then we've got hydrogen gas. Hydrogen gas is elemental hydrogen, so it's diatomic, all right, and it is in gas form, so we put the G there. All right, so that is how that works. Again, typically you would balance this after you were done, but because we have that other part of the test that is focusing on balancing, this is the end of what you have to do on this problem. And then here, just this last part that I've already written in. This is talking about what's happening in a chemical reaction. So it says atoms are being rearranged, bonds are being broken, new bonds are being formed, the number of atoms on each side is the same. All right, and so what's happening here is the atoms themselves are not breaking apart unless we're talking about a nuclear reaction, which we just don't really ever even talk about in this chemistry class. And so the atoms, really, they're staying intact, and all that's happening is the way that the atoms are linked are changing. And so what's happening is bonds are breaking, new bonds are forming, right? And then you keep, based on the law of conservation of matter, because the atoms aren't being broken up, all right, you're going to have the same number of atoms of each element on both sides. That's how chemical reaction is occurring. And the way I think about this is actually like atoms and molecules are always moving around. And so what happens in a chemical reaction is really just one atom or one molecule strikes another, all right? And then I think of them as sort of like swirling around each other. Bonds break and the atoms kind of swirl around each other and new bonds form, all right? And then that's the end of that. Okay, so that is what a chemical reaction is like. Conceptually speaking, there are quite a few things I could ask you about in this unit. So again, just really make sure you look through that set of notes from the beginning of this unit. Make sure that you have a good understanding of the concepts. Make sure you have a good understanding of the vocabulary. Just go through lots of practice when it comes to the predicting products and the balancing chemical equations to make sure you're good with those skills. And if you need any help before the exam, make sure you stop in and ask.